This video gives a brief overview of our work in the aviation thread of OGC OWS-9 in the field of geometry processing. For this research topic, we analyze the potential use of web processing services for geometric calculations that are important in the field of aviation. A web processing service, or WPS for short, is an OGC standard that allows you to define a service to perform generic calculations on input data. The output of the calculations can be anything ranging from simple literal values to complex XML documents or even binary images. Specifically for OWS-9, we analyze two potential use cases. First, we look at calculating the intersection points between two separate axon features. Second, we looked at determining the spatial relationship between two axon features. These use cases have been inspired by a flight dispatching task, namely the analysis of airspaces that intersect with a flight route. The intersection profile defines a single process with a very simple goal: to find all intersection points for two given axon features. As input, we have two axon features embedded into our WPS query. The output of the operation is a GML multi-geometry element that contains the resulting intersection points. The multi-geometry element can be empty, meaning that no intersection points were found. The spatial relation profile defines a set of Boolean spatial relation operations on some axon features. Some examples of available operations are contains, covers, crosses, and so on. As input of these operations, we have two axon features embedded into the WPS query. The output of any of these operations is a literal Boolean value that either confirms or denies the spatial relationship between the two given axon features. The following video demonstrates the Luciad Aviation client implementation connecting with both 52 North and Luciad-based WPS servers. To demonstrate the intersection profile, we first select an axon route segment and an axon airspace. We then choose to calculate the intersection points from the drop-down box and hit the Process button. This sends our query containing the two axon features to the WPS server. The result is a set of points that are visualized as crosses on the map. To demonstrate the spatial relation profile, we again select an axon route segment and an axon airspace. Notice how the route segment is drawn over a large geodetic line. All of the calculations on the server are performed geodetically to allow correct spatial relation calculations for a large geometric shape, such as this route segment from Europe to North America. We hit Process, and we find out that our route segment does intersect with our selected airspace. When we zoom in, we can clearly see that this is correct. Finally, we perform the same spatial relation operation on a different airspace. This time, the WPS server tells us that the airspace does not intersect with our selected route segment. Our main accomplishments are that we've defined WPS profiles to support topology and intersection calculations for the aviation domain. We've also created working implementations of the profiles as proof of concept, as well as integration into a client. And finally, we've demonstrated real-world use cases to support ATC-ATM operations. The main benefits for using WPS services for geometry processing are to turn common calculations into reusable components for easy sharing between applications, and to offload heavy computational tasks from lightweight clients to the server. Thank you for watching. For more information regarding our research, please consult the OGC OWS-9 Aviation Architecture Engineering Report.